Today, we'll discuss the past year in 2021 question 17, which is about the photoelectric effect. In an experiment to study the photoelectric effect, the variation of the photoelectric current with the potential difference across the cathode and anode is shown in the graph. So the monochromatic light of wavelength 250 nanometer is irradiated on the surface of the cathode. Determine the maximum speed of the photoelectron. So like I mentioned before in one of my videos, we have two things to know. First is the stopping potential, which is the potential, the reverse potential needed to stop the electron with the highest kinetic energy. So determine the maximum speed of the photoelectron is that we can refer to the theory of the stopping potential, that EV equal to half mv squared, where the potential difference here is the reverse potential in the graph, okay, the x-intercept value. So put in the values that the electron charge multiply the potential difference 3 watt equal to half multiply the mass of the electron v squared. So the answer here will be equal to 1.027 times 10 to the power 6 meter per second. So next is to calculate the threshold frequency of the incident radiation to produce photoelectrons. So we are going to refer to the Einstein equations that energy is equal to the work function plus the kinetic energy. So we are given with the wavelength, so the energy could be expressed as hc over lambda, and the work done as we have derived before, it is equal to hf naught, that the f naught is the threshold frequency. So the kinetic energy here, you could apply the half mv squared, or I would prefer to apply EV because the value given is the original value that without the rounding value. So put in the values and you should be able to obtain the threshold frequency is 4.75 times 10 to the power 14 Hertz. So we move on to the last question. If the experiment is repeated using the monochromatic light of shorter wavelength but the same intensity, sketch a curve to show the variation of I with V on the axis of the graph above. So we are given with 3 marks, so it could be 3 points to be noted in the graph. So I've listed out a point here, few points here. So the shorter wavelength should means that the light has a higher photon energy. So photoelectron receive more energy and has higher kinetic energy that require higher stopping potential. So when V is equal to 0, photoelectron which move faster can give higher current reading. And with the same intensity of light received, saturation current should be the same at 6 milliampere. So I guess these should be the 3 points that you should be considered when drawing the graph, okay, when sketching the graph. So we have the higher stopping potential and higher current value when the V is equal to 0, and it's still maintained as the same saturation current. So the sketching of graph should be something like this. So I guess that's all for this question. Thank you.